Okay, let's go through the Chapter 2 test. So, um, first question, we've got to differentiate, and we have this mess times this. So we got a product rule. Product rule, we take the derivative of the first times the second plus the derivative of the second times the first. Derivative of the first, derivative of 3x is 3 plus the derivative of 2 times x to the third is 3 comes down times the 2 makes 6x squared, lower the power by 1. Derivative of the first times the second plus the derivative of the second. So the derivative of sine of something is the cosine of that stuff times the derivative of the inside. So the 2 comes down times the 5 and makes 10. X to 1 less than 2 is the 1 power. So there's the derivative of the second times the first. That's it. Okay. Now we're supposed to find the slope of the tangent line at point 2. And so we have cotangent to the third power. So we got stuff to the third. The chain rule says, okay, if we got stuff to the third, we take 3 times that stuff, whatever's inside, to 1 less power squared, and then we take times the derivative of the inside, which the next level, the next Ukrainian doll is a cotangent of some things, and the derivative of cotangent is negative, and we're multiplying, negative cosecant squared of, leave the stuff alone, 3x plus 4 times the derivative of the inside on the third level of the third layer. So we got the cubed as the outside layer, cotangent of stuff, the second layer, and then the stuff inside the third layer. And the derivative of 3x plus 4 is simply 3. Now, we have to put in point 2 in for the x's. In cotangent and cosecant, you can type them in on the calculator, in on Desmos like that, but on calculator there's no cotangent or cosecant button, so you have to know how to type those in. So the 3 times the 3 is a 9, and cotangent is 1 over tangent, and this is of 3x plus 4. And we got a square. Or we could type in tangent of 3x plus 4 to the minus 2. That the minus would make it 1 over it squared. Then we have a minus here that's times thing, so I'll just put that out in front. And then cosecant is 1 over sine, so we could type this in as 1 over sine of 3x plus 4, and again the whole thing is squared, not the minus. The minus was not squared, just the cosecant is squared. Or we could type it in as sine of 3x plus 4 squared. So I'm going to type that in. I'm going to check and make sure my mode is in radians. It is. And to make things easier, I'm going to go 3 times 0.2 plus 4, which is 4.6. So this 3x plus 4 is 4.6 when I put in 0.2. So all I have to do is, move this up here a little bit, is to type in -9 parenthesis tangent of 4.6 close parenthesis to the -2 sine of 4.6 to the -2. And I get 0.116 negative. Okay. Page 1. Page 2. Find the equation of the tangent line. So we've got to get the complete tangent line. And we got some x's and y's, and we can't solve for y. So we have to do implicit differentiation. So the derivative of x to the third is 3x squared times the derivative of the inside, but it's just an x, so we don't need to, plus derivative of y is 1 times the derivative of the inside, which is dy dx, because it's not an x, equals 0.5 derivative of ln y. Derivative of ln, if anything, is 1 over that stuff, times the derivative of the inside. Derivative of y is dy dx. 0.5 is 1/2, so this is 1 over 2y, or 0.5 over y, either way. But we subtract 1 dy dx from both sides, and so we get 3x squared equals, I'm going to call this 1/2, so it's 1 over 2y minus 1. Both of those are times dy dx. So then I can divide by this now, or I can just put in my -1 and my 1. My -1 in here squared would be 1 times 3, so I get 3 equals, and put my 1 in here, so I get 1/2 minus 1, which is minus 1/2. To get rid of that minus 1/2, I multiply by -2 on both sides, and that cancels that, and I get -6 equals dy dx. So I found the slope at 1, -1, but I'm supposed to find the equation of the tangent line. So the tangent line at A equals -1 is the slope times x minus a -1 plus the y value at -1, which is 1. Okay, now this one. We're supposed to just find the derivative. And y is solved for, so this is pretty straightforward. It's going to be dy dx equals quotient rule. So that looks like derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. Derivative of the numerator. Derivative of e to any power is e to the same power times the derivative of the power, which is -5, times the denominator. An arc sine is the same as sine to the -1, sine inverse of 4x, minus derivative of the denominator. Now the derivative of the arc sine is 1 over the derivative of arc sine of x dx is 1 over the square root of 1 minus x squared. So whatever's inside goes in here. We have 4x, so it's 1 over the square root of 1 minus 4x quantity squared times the derivative of the inside, which is a 4. The derivative of 4x is 4. So that's the chain rule. The derivative of the secant times derivative of the arc sine derivative of the arc sine times the derivative of the inside times the numerator, e to the negative 5x over the denominator square. Okay, page 3. Now we have to find over what interval, determine the interval for which this function is differentiable. Now you could just type it in a graph, but ln, this at 4 to the any power, the power can be any number. So this part is differentiable everywhere except this part that it's multiplied by, ln of negative x. You can't take logs of 0 or negative numbers. So if it's negative in here, x is going to have to be negative to make them positive numbers. So it's differentiable over the interval from negative infinity to 0, and not including 0. There's 4 points on this one. Then the other points are, we got to find the equation of the tangent line, which means we need the slope. So we got to find the derivative, and this is a product. So the product rule is the derivative of the first times the second plus the derivative of the second times the first. Derivative of 4 to the x is, the x is in the power, so it's the same thing, times ln of the base. That's the derivative of the first times the second plus the derivative of the second. The derivative of ln of something is 1 over whatever that is times the derivative of the inside, and the derivative of negative x is negative 1. That's what a lot of people missed on the test. They didn't take the derivative of the inside. Times the first. So there's this. We could do some simplifying. Let's see. There's a 4 to the x in both parts, so it could go 4 to the x, and we have ln 4 times ln of negative x plus the negative 1 times 1 over negative x is just 1 over x. And so we can plug into this at either 1 or negative 1. Well, we can only do the negative 1 because of this here. ln is only exists at negative 1. So we can't put in the 1. This would give us ln of a negative number. Can't do it. So we're doing negative 1. So 4 to the negative 1, of course, is 1 over 4, 1/4 ln 4 ln of 1, which is 0, plus 1 over negative 1, which is negative 1. So we get 1/4 times negative 1, and 1/4 times 0, and they add up to be negative 1/4. Didn't even need my calculator that I was pulling out. And so the equation of the tangent line at a equal negative 1 is going to be the slope times x minus a minus 1 plus, now we need to know f at minus 1. So this would be 4 to the minus 1, which is f of minus 1 would be 4 to the minus 1, which is 1/4 ln of minus a minus 1, ln of 1, and ln of 1 is 0, so we get 0 times 1/4, or 0. An object is thrown straight up at 105 feet per second, and this would be the equation if it's thrown 60 feet above the ground. And this is due to gravity on the Earth. So the velocity is just the h prime of t is the velocity equation. And so 2 times negative 16 is 9 is 32 t to the 1 plus 105 t. Derivative of 60 is 0. So this would be a velocity. So the units on this, if I put a number in for t, should come out to be feet per second. Now the acceleration, the derivative of velocity with respect to time is acceleration. And if I take the derivative of this, I get negative 32. And that's it, it's just negative 32. The units would be feet. See, the velocity is feet per second, so the derivative of that would be change in the velocity, which is feet per second, over the change in time, which is in seconds. So it's negative 32 feet per second squared. And it says find the velocity at 2 seconds. So we put 2 in there, we get negative 64. Oh, not a t here. Sorry. Derivative of 105t is just 105. Wow. Sorry about that. So the derivative at 2, we put 2 into here, we get negative 64 plus 105, which is 41 feet per second. All right, on the back page. It says, using the table of values in the central difference theorem to determine the derivative of f of 0.5 plus g of x at x equal 1.4. So we've got to find the derivative. We have stuff inside of a function. We have to use chain rule. So it's the derivative of the big picture, f prime of 0.5 plus g of x, leaving the stuff inside alone, derivative of the big picture, times the derivative of the inside. And the derivative of 0.5 plus is just 0, so we don't have that, times plus the derivative of g is g prime of x. And that's the derivative. So now we got to find the slope at this place. But what is this place? Well, if x is 1.4, what is g of 1.4? So I'm coming down here, and it's 0.7. So g of 1.4 is 0.7, so I have to find the slope at 0.5 plus 0.7 is 1.2. And then I have to find the slope of g at x, which was 1.4. So at 1.2, to find the slope of f using the central difference, it's going to be 0.71 minus 0.83 over 1.3 minus 1.1 times, then the g at 1.4 will be 0.67 minus 0.74 over 1.5 minus 1.3. Now to work that out, let's see. 0.71 minus 0.83 is negative 0.12 over 0.2 times, and 67 to 74 is negative 0.07 over 0.2. So I got a negative times a negative, which is positive. And 0.2 into 1.12 is 0.6. And 0.2 into that is 0.35, I believe. Doing this in my head, so I better check these. So I've got 0.12 divided by 0.2, 0.6, and 0.07 divided by 0.2, 0.35. And if I multiply those, I get 0.21. And the bonus question: to derive the derivative for arcsine, arcsine is just sine inverse, which means it was the sine of y equals x, and somebody took the arcsine of both sides to undo the sine, so the original equation probably was sine of y equals x. And then we can take the derivative of this, and so implicitly, so the derivative of sine is cosine of whatever was inside times the derivative of the inside, which will be a dy dx equals, and the derivative of x is just 1. So the derivative is just divide both sides by cosine y is 1 over cosine y. Now if we go back to the original sine of y equals x and draw a triangle, make the angle y, and the sine of y was the opposite over the hypotenuse, and doing a squared plus b squared equals c squared. If I call this a, then it's a squared plus x squared equals 1 squared. And so I subtract x squared from both sides. And so a equals the square root of 1 minus x squared. So the cosine is adjacent over hypotenuse, so it's 1 over the square root of 1 minus x squared.